So we're going to do another problem with compound interest. So we want to remember the compound interest formulas. So one of them says A equals the principal times 1 plus the rate divided by n to the power of nt, where p is the principal, r is the rate of return, the percentage rate that you're earning, n is how many times it's compounded in a year, and t is how many years. That's one formula. The other formula is PERT, and that's for when it's being compounded continuously. Compounded continuously. So you only use the PERT formula if they say, in this example, we're going to compound continuously. If it's quarterly or monthly or daily, then you're going to use the other formula. And they have to tell you. Okay, so it says Hector invests $10,000 at age 21. He hopes the investments will be worth $150,000 when he turns 50. If the interest compounds continuously, okay, so compounded continuously, that means we need PERT. Approximately what rate of growth, so we don't know the R, will he need to achieve his goal? Okay, so we know he's starting with $10,000. That's going to be the principal. We know he's got from age 21, he's 21 right now, and then he's going to be 50. So how many years is that? He's got 29 years for the investment to grow. So T is going to be 29 years. Okay. And then how much does he want when it's all said and done? He wants the A, the amount in the account, to be $150,000. Okay. And we don't know R. That's what we're looking for. That's what we don't know. Okay, so we'll go to the formula and put this information in. So we've got 150,000 equals 10,000. E, remember E is a value, so we're okay with that. We've got that on our calculators. And then we have R, which we don't know, and then T is 29. So I'll just put 29R up there. I feel like stuff's moving around over there. Okay, so time was 29, and the rate we didn't know. So, okay, I want to solve this. Now, we just did an example, something like this. We're going to get rid of that coefficient right off the bat. So divide both sides by 10,000. And on the right, I get e to the 29r. On the left, well, I've got 4 zeros in the denominator and 4 there, so I'm going to get 15. Now, you could work that out on your calculator, but that's a little trick when you're dividing by powers of 10, or when you have those zeros. Okay, so that looks a little more friendly. Now, how are we going to solve this? I'm going to use a natural log. So if I take the natural log of both sides, natural log 15 equals natural log e to the 29r. Well, on the right, you could say 29r times natural log e, but all of this is just equal to 1. Okay. So that's the great thing. When you have the e in the equation, you apply the natural log, and then that makes it a little bit easier. We also have property 3, if you don't like thinking about it the way I just showed you, that says log base a of a to the x just equals x. So when you have a natural log of e to, whatever, that's just going to equal the exponent. So right here, I can just say that whole thing on the right is just going to be that exponent, 29r. That would save me a little bit of time. Okay, so now I have the natural log of 15 equals 29r. So I want to solve for r. I'm going to divide both sides by 29. And r is going to be, now, this is the exact answer, natural log 15 over 29. But my guess is they want us to approximate. They didn't say how much they wanted approximated to. Let's put it in our calculator and see what we get. So 15, oops, sorry, no, don't do that. natural log, it's got to be natural log, 15, close the parenthesis off, divide it by 29, and I get R is approximately 0.09338, and then it keeps going. So it's a decimal. I need to change it to a percentage rate, a rate of growth. So go 2 places. So it's about 9%, 9.3%. Okay. Hopefully they'll tell you how accurate they want it to be. If you were taking a test and they didn't say, I would accept 9% or 9.3%, 9.33%.